You alright?
Yeah.
He's called chemical.
I didn't. Alright. A chemical reaction is an event. Well, everything's an event.
I question there.
What?
Is it starting off a new series?
Yeah, this will be 6-1. This will be the new chapter.
Is the chapter called chemical reaction?
Yes. It is actually.
Okay.
Maybe my tie shirt.
Yeah. You're trying to remind me about the time I said.
Alright, you go to class.
Damn.
I have to wait for Sean to get done with your boyfriend.
Ooh, that's weird. Yeah, multiple.
Look at it.
Atoms or elements or compounds are combined, separated, or rearranged. Okay, so this means we've talked about bonding, right? Covalent bonds, ionic bonds. So a chemical reaction is when you have separate atoms and they come together and make a bond, or you have atoms that are bonded and you break the bond, or one atom takes the place of another atom in a compound. Those are chemical reactions. And we'll talk about the specific types later, but that's just kind of a general definition. In everyday life, there's some places where we see chemical reactions, actually a lot of places. So where do we see chemical reactions in everyday life?
In chemistry room.
That's a terrible answer, obviously you see them here. Let me give you just to list some things. Whenever you see something rotting,
It's a baking soda.
just sitting there, that wouldn't be a reaction. But what you said is right. Cooking is usually a chemical reaction. When you cook things, they change color, they give off gases. There's usually a reaction taking place. Even toasting bread, when it changes from white to brown, that's a reaction. Some of the hydrogen's given off from the starch into your bread. Digesting food, lots of chemical reactions going on in your body. And in other places, but in digestion a lot. Fire, anything burning, that's a chemical reaction. That's a reaction involving oxygen. Huh? I knew what you said.
He said it's like my mixed tea.
Mixed tea?
Oh my God.
Mixed tape?
Yes.
Yeah, his
Like
mixtape's
his
fire.
was on point.
Oh, alright, I see. I'm
Wow.
gonna have to edit that out though unless you pay for the commercial.
Is freezing one?
Freezing, no. Freezing, melting, boiling, change of state is not a chemical reaction. And that's the one people usually mistake. And one more. What else do I have on this list? Rusting or any kind of corrosion.
What's that? Oh, corrosion? What's,
So when iron turns brown, rust, that's a chemical reaction.
It's not really the same as rust.
Huh?
It's not really the same.
rusting is like the rust.
I can't hear what you're saying. I can't hear you over on with Dave. She was interrupting me. Rudely interrupting me.
Big one.
Go ahead.
Isn't rotting the same as rusting?
No, rotting would be food going bad. Usually involves some sort of living organism making it happen. I mean, things can rot on their own, but usually there's like bacteria or something else speeding it up. Rusting would be like metal or something. Copper corrodes, changes from brown to green, same thing. That's also a chemical reaction. Alright, next thing. Chemical reactions. That's an N. Can be represented with chemical equations. All right, so there's two ways to write a chemical equation. I'm running out of space, so I have to erase at the top. Everybody good there? All right. So two types of equations. Word equations. I guess there's really more than two, but these are the two that we do. And formula equations, which are also sometimes called skeleton equations. So let's look at hydrogen burning, and we'll show the chemical reaction using word equations and using chemical or formula equations. So word equation would look like this. You would have hydrogen, hydrogen plus, if it's burning, what's it reacting with? Oxygen. Okay, so these are the two reactants, and the way you know they're the reactants because the arrow points away from them. And what does that produce? Water. Right. You kind of should have guessed that because hydrogen and oxygen, the only compound you probably know of that has hydrogen and oxygen is water. Yes, H2O. The other compound that you see in everyday life that's hydrogen and oxygen is peroxide, but that doesn't usually get named.
Hydrogen.
All right, let's show the same reaction using a formula equation. So that would be H2. The reason we write H2, hydrogen is diatomic. They always come in pairs. You don't have single hydrogens because they're very unstable, so they stick to each other, like always two stuck together, until they react with something else, then they can be singles. Reacts with oxygen. Oxygen's another one. It's also diatomic, so it's always O2. You're never going to have just O by itself unless it's in a formula with something else. And they produce H2O. And you're wondering, where does the extra oxygen go? It ends up reacting with two more hydrogens. We'll talk about that another day when we do balancing equations. But just whenever you see these twos, just think like these things come in packages of two. You just can't get them by themselves. You're like something that you buy in the store comes in twos. All right. So word equation, formula equation. That's it for that. That's mostly what you'll do on the worksheet today, is just write the two types of equations. Last thing I wanted to go over, signs of a chemical reaction. I kind of threw that into this lesson because it's pretty basic and straightforward. Today's like a lot of introductory stuff, so just kind of want to get it out of the way. All right, signs of a chemical reaction. There's 4 of them. Who knows one? Explosion. So in an explosion, what do you see?
Smoke.
Smoke.
Smoke, so gas is given off. So it could be smoke, it could be steam, it could be bubbles if the reaction's happening in solution. It could also be a smell. All those are gases given off. So yeah, usually when you smell something, a chemical reaction's happening. What else? Temperature change, right? You see that in explosion too. So it could be heat given off, it could be heat taken in. Sometimes something will react and it'll get really cold, like those ice packs the nurse gives you. There's the solid stuff and the liquid, and when you mix the two together, they react and you get a temperature change. What else? One more obvious one. Color change. Color change. And the last one, I don't know if you're going to get it or not. Last one is precipitate. So this would be like, say for example, you mix 2 liquids together and then suddenly some solid stuff comes out of there. That would be precipitate.
Oh, like, when we did that lab, and then, like, it froze inside the thing.
The sodium acetate when it crystallized?
Yeah, that.
It was kind of, yeah, well, sort of, yeah. Although that wasn't a chemical reaction, it was just coming out of solution, but that's what it kind of would look like. Well, they usually precipitates just fall to the bottom, kind of look like a little pile of dirt or metal or something, pieces of stuff. All right, questions on any of this?
Nope.
All right, we are done.
Hold that, Chauncey.
This the right one? Nope, that's wrong. This is the right one.